move all zeros to the end without changing the order of other elements. Example, my input is 0, 1, 0, 3, 12. So all the zeros will move to the end and my output will be 1, 3, 12, 0, 0. And the order of elements like 1, 3, 12 stays the same as in the original array. Let's see how we can do it. Let's take an extra array. Then we'll loop through the input array, and whenever we find a non-zero, we'll insert that in a new array. So here I'll skip first 0, insert 1 in the new arrow, skip the next 0, insert 3, and then insert 12. We'll do this till the end of the array. Now we can either count the zeros or simply fill the empty spaces with the zeros if we already defined the array's length. This is our first solution using extra array. Time complexity is O of n because we are using just one loop. Space complexity is O of n because we are using an extra space of the same size, and it is not in place operation since we used extra space. But can we come up with a better solution? One that saves space, maybe even time? Pause the video for a moment. Think about it. Grab a pen and paper. Treat it like a fun puzzle. Okay, here is a little hint. We can solve this using 2 pointers. Pause again and give it a try. Let's go. I'll use 2 pointers. I'll name them as insertion pointer and running pointer. Initially both are at 0th index. Now I'll loop the running pointer over the array. So it will loop through the numbers 0, 1, 0, 3, 12. While visiting each number, we'll check, is the number 0? If yes, then we do nothing, move to the next number. In our example, the first number is 0, so we skip it. Next is 1. Is it 0? No. Here is what we do. Since it is not 0 and our insertion point is still at index 0, we place the current number at the insertion pointer's position. So array at index I equal to array at index R. Basically we move 1 into the first position, actually 0th position. Then we increment the insertion pointer. Now the insertion pointer, the one in blue, move 1 step forward. We continue the loop. Running pointer moves to the next number. Another 0. It's 0, so we can skip. Running pointer goes to next and finds 3, which is non-zero. So check where the insertion pointer is. It is at index 1. We place 3 there. After that, we increment the insertion pointer. Let's keep going. Running pointer is at 12, which is non-zero. We place it at the insertion pointer's position and increment the pointer again. Now we have completed our loop. All we need to do now is from the insertion pointer till the array, till the end of the array, fill with zeros, and boom, we are done. And guess what? We did it without using an extra array. And time complexity is the same. Now let's look at the code. It is super easy. In the function, we assign insert is 0 and loop the running pointer over the array. As per logic, if the number is 0, we do nothing. So I'll skip this condition completely. Instead, I'll write if the number is not 0. Then place the number at insertion pointer's index and increment, that is array of insertion is equal to array of running, and increment the insertion pointer. At the end, from the insertion pointer till the end, we set the remaining values to 0 using this line. And this is the code. Let me run this. And yep, it works perfectly. It gives me the correct result. And hey, if you want to see what's happening in each step, just add print statement in the loop, and you can dry run how the array changes on each iteration. Thanks for watching till the end. Do subscribe to my channel. Check out the full DSA series in Python. See you in the next one.